All right, the last thing we want to look at for this section of series is this special sum, the sum to infinity, also known as the limiting sum. It only works for geometrics and if the ratio is smaller than 1. So basically the series will converge down. So if indeed that ratio is less than 1, and the reason it works, if you think of the exponential curve, our basic exponential, r to the power of n, we know as n approaches infinity, if r is less than 1, well, you could think of it as the negative exponential, couldn't you? Because it'd be like, say, to the power of -2 or -3. So if you think of your negative exponential, as n approaches infinity, that curve's going to approach 0. So that limit will be true if the ratio is less than 1. It converges down to 0. So therefore, the limit for our sum, well, the r to the power of n, that's converging down to 0, and so we just get a on 1 minus r. So that's the formula we can use for sum to infinity. As I say, it only works because the ratio is less than 1. If the ratio is bigger than 1, then we'd have our regular exponential curve, and it's not converging, it's going off to infinity. So this sort of question, does this have a limiting sum? They like those sorts of questions because it's easy if you know the definition. So we have a look at it and go, well, let's see. Second term divided by the first term, well, that's certainly less than 1. So theoretically, I should check and make sure it is geometric, but 2/7 divided by 4 is also 4/56, so that's okay. So we know the ratio is in between -1 and 1. So yeah, it will have a limiting sum. A half, a quarter, plus an eighth, a classic series. The frog in the well. They're at the bottom and they can only jump half as much each time. When you think about it, it's a pretty stupid frog. But, well, no, because they're at the bottom, right? And they jump up half. And that's okay, fine, you'll view it. Next jump, a quarter, then an eighth. Now, at some point, they're getting really close to the end. Why they don't just take one step and get out of there? Oh, no, I can only jump a half of what I just did. And it never gets out. Because if we add all those up, A is a half, R is also a half. So our sum to infinity, subbing in, equals 1. So could this little frog do an infinite number of jumps? It'd get right on the edge of the well, but it would never get out. Stupid frog. Right. Now, we've seen this sort of question before, and if they wrote the question like this, I'd just write the answer down, which is, of course, 36/99. But sometimes they might say, by writing it as an infinite sum. And in that case, they've tied your hands. So we would rewrite it as 0.36 plus 0.0036 plus 0.000036 plus 0.00000036 plus 0.00000036, well, you get the idea. It turns out to be a geometric series though, because the ratio is just 0.01 and it's going off to infinity. It is converging down. And so we sub into a on 1 minus r, and we get, well, 0.36 on 0.99, but we don't normally write decimals on decimals. So that's 36/99, which we were expecting. But as I say, if they just say, if they're silly enough to just say, write 0.36 as a fraction, or 0.36 repeated as a fraction, don't waste time. Well, it's 36/99. It's only if they tell you the method that you have to use that you go, oh, damn. That'll do it.